All right, a topic that gives students a lot of problems is the idea of mass versus weight. And these are two very, very different things. First off, mass, to give mass a definition, mass is the amount of matter in an object. All right, so it's the amount of matter, the amount of molecules that make up any given object. Weight, however, all right, I'm simplifying these definitions. Weight is the force due to the pull of gravity. All right, so mass, the amount of matter in an object, and weight is a force caused by the pull of gravity. And to kind of illustrate that, let me give you an example here. Let's say here I am standing on Earth, and my mass is 100 kilograms. Okay, I fly to the moon. Here's the moon. Here I am standing on the moon. All right, my mass is still 100 kilograms because that's the amount of matter that I'm made from. All right, I didn't lose a limb. I didn't go on a crash diet. I didn't pig out and become, 20, gain all this weight. All right, I stayed the same amount. I'm 100 kilograms on Earth, and I'm 100 kilograms on the moon. All right. Now, weight, on the other hand, remember that weight has to do with gravity. And so on Earth, I'll draw this here, the pull of gravity is 9.8 meters per second every second. And, you probably don't understand what that is. That's a topic for another video. So if you drop an object from the sky, it's going to fall at a rate of 9.8 meters per second every second. All right. Now, if you remember the formula for force equals the mass of an object times the acceleration. So to find the force or the weight of me on Earth, I'm going to multiply the mass, 100 kilograms. All right, multiply that times the gravity. All right, the acceleration of gravity, which is 9.8 meters per second. Okay, and that is going to give me my weight. And so I multiply that out, I get 980. And if I use these units, it would be something called kilogram mass times mass over second over second. All right, that is equal to something called a Newton. All right, so I know this is confusing. So in other words, the mass times the acceleration is going to equal 980 newtons, and that would be my weight. If, on the other hand, I went to the moon, remember my mass would stay the same, 100 kilograms, but my acceleration, the acceleration of gravity on the moon is only 1.6 meters per second. The gravity is not nearly as strong on the moon than it is on Earth. It's only 1.6 compared to 9.8. So I multiply my mass times the gravity, 1.6 meters per second, and that's going to equal 160 newtons. Okay, so to show you my mass, 100 kilograms, my mass stayed the same. However, my weight, 980 newtons on Earth, as opposed to 160 newtons on the moon. All right, now let me show you a little table here. All right, so let's look at this table. All right, and if we use the mass that I use, that I was talking about before, if we keep it at 100 kilograms for all of these examples, 100, 100, 100 kilograms, and we said on Earth acceleration was 9.8. On the moon it was 1.6 meters per second. On Mars it is 3.7 meters per second. And then on Jupiter, which has an extremely strong force of gravity, it's going to be 24.8. All right, so with that information, all right, on Earth, my weight, remember this is weight. Weight is a measure of force. My weight is going to be 980 newtons on Earth. On the moon, my weight is going to be 160 newtons on the moon. On Mars, my weight is going to be 370 newtons. And then if I travel to Jupiter, my weight is going to be, let's see, 2,480 newtons. So you can see, given that my mass stays the same, I travel to the Earth, I travel to the Earth. I'm on Earth, and I'm 980 newtons. I travel to the Moon. I'm much lighter. All right. Mars, I'm only 370 newtons. But if I go to Jupiter, I get much heavier by weight because the gravity is pulling me down more, at a very strong force, and it's 2,480 newtons. All right, so I hope that clears it up a little bit, and see you on the next video.